Okay, in question 6, we start with partial fractions laid out as is this, and it's partial fractions where we've got a quadratic over a quadratic effectively. Consequently, we actually get a whole number, an integer, as part of our answer, plus some remainder, and then that remainder over 2x plus 1, 2x minus 1 can then be split into two partial fractions. So to start with, the method that I tend to use would be so long division initially to get the whole number and crucially the remainder, and then once we've got the remainder over this denominator, we're going to split that into partial fractions. Okay, so what we're doing is we are dividing the numerator, which, sorry, that's a bad idea. Let's push that 2 through it straight away. So we have 8x squared plus 2. So we're dividing that by this. Now, similarly, I'm going to expand the bracket straight away. So 2x times 2x is 4x squared. 2x times minus 1 minus 2x plus 2x, well, they cancel out, and then minus 1. So how many 4x squared minus 1s go into 8x squared plus 2? So initially then, well, that's going to be how many 4x squared go into 8x squared? Well, that's 2. When we do the multiplication, that gives us 8x squared minus 2. Okay, and then when we do our subtraction, they cancel obviously. 2 minus minus 2 is plus 2, so we end up with 4. Okay, so initially then, what we know is that in part B then, we're asked to integrate this, and it's a hence, so it's directing you to use the answer to part A. In part A, we established that this was equivalent to 2 minus 2 over x plus 1 plus 2 over x minus 1. 2 over 2x minus 1, rather. Okay, so that's what we're really going to be integrating. I'm going to be integrating between 1 and 2. So, integrate 2 with respect to x, we get 2x. Integrate 2 over 2x plus 1. Well, if you integrate a reciprocal function, we get ln. So that's our kind of starting point. Now that 2 there is a multiplication by 2, so that just sort of stays as a constant multiplier. Ln then of 2x plus 1, but because our inside function there is 2x plus 1, it's linear. First of all, it allows us to do the integrate it at all, but it means that we need to divide by the coefficient of x. Okay, so if the inside function is linear, we then divide by the coefficient of x. So I'm going to tap that on as a times by a half at the end there. And that sort of process is going to be repeated here. So that 2 at the top is a constant 2. Integrating a reciprocal function, we get ln. Reciprocal linear function, I should say, get ln. And then the inside function is 2x plus minus 1, so we times by a half to enable us to divide by that 2 there. Okay, now we can see that the 2 times a half, they're going to cancel. 2 times a half, they're going to cancel. Now, what we're then left with, though, are 2 ln functions which could be combined. I mean, we don't have to do it straight away. We could substitute the 2 and the 1 in first, or we could combine them straight away. Since we've thought about it, let's combine it straight away. So we've got a positive ln at 2x minus 1 and a minus ln of 2x plus 1. So if you've got ln of A minus ln of B, we get ln of A over B. So we divide them, divide the insides. Okay, so it's going to become plus ln of this divided by that. Okay, and now we're ready to substitute in our limits in quite a tidy way. Okay, so 2 goes in then, so 2 times 2. One goes in. Okay, so 2 times 2 is 4 clearly. Ln of, on the numerator we've got 4 minus 1 is 3. Denominator we've got 5. That's a 2. That's a minus 2 minus ln of, this time 2 minus 1 is 1. 2 plus 1 is 3. Okay. So 4 minus 2 is 2. Plus ln of, so plus ln of 3 over 5 minus ln of 1/3. Well, again we can do a division, so plus ln of 3 over 5 divided by 1 over 3. Now if you do 3 over 5 divided by 1 over 3, you flip the second and multiply. Okay, so that's going to give us ln of 9 over 5. Now at that stage, let's just check back to the format and the question. What's the question asking for here? 2 plus ln k, given the value of the constant k. So k then would be 9 over 5.